And this solution, this question of demand-side management, it's really a key issue, because it can only be successful if it results from a combination of two approaches. An active energy management by the consumer himself. We assume that the consumer will accept to a certain extent to manage his consumption. But to which extent, it has to be debated. We don't know exactly how interested will the consumer be in managing their the electricity demand. And the second approach is a remote energy management. What we are doing in France for water heating, but it could be applied to other applications such as household appliances, washing machine, etc. Will it be accepted by the consumer? Because it raises a lot of questions, including question of privacy. Because you will have your own equipment in your home managed by your electricity supplier. Will you accept it? We don't know. Maybe. There was this demand-side management implies that we install everywhere smart meters. Smart meters are often confused with smart grids, but smart meter is only a piece of the cake. It's an element of smart grids. They are necessary, but they are not the whole solution. Now, smart meters are developing almost everywhere in the world. We consider that today there are circa 8 million smart meters installed around the world. Notably in Italy, there are a lot of smart meters. In California, PGE has now around 6 million smart meters installed. And in France, we are today launching the Link project, which will be more than a meter. It will be an intelligent meter. It's a project which is launched by the grid operator, which is ERDF. It's a subsidiary of EDF, but independent from EDF. And the first step of this project is to install 300,000 meters in two regions, one close to Lyon, another one near Nantes, near Tours, in the western part of France. And then, if this experiment is successful, it will be generalized to the 31 million users we have in France. Well, the principle of this experiment is to have smart meters in each home, connected via how do we say in English, power line carrier system to concentrator, and then the information is transmitted via GPS system, something more derived from GSM, and then it's exploited by the information system of the grid. Where do we stand today? We are just, let's say, in the middle of the experimentation. Not all the meters are yet installed. It's more difficult than anticipated. It costs more than what we anticipated. And we have not yet feedback about the efficiency, because people have these meters, they look at them and say, what could I do with them? I mean, the system is not integrated yet. A few words about electrical vehicles. France now has a very ambitious policy regarding electrical vehicles, because we would like to have in 2020 2 million electrical vehicles in France, including rechargeable hybrid vehicles. This is a very ambitious. Bon, we make the assumption that the batteries will be available. I know that in this country there is a lot of research which are carried out about batteries. We have a French company, Bolloré, which, as far as I know, is testing some equipment in Israel. but the reliability of the battery is still questionable. Let's assume that they will be sufficiently reliable. So the objective would be to have 2 million electrical vehicles in 2020. The problem is not only with the battery, it is also with the charging station. And we are currently standardizing on 3 types of charging station. The home station, or station at work, which will require 8 hours for a car to be fully recharged, but with a power limited to 3 kilowatts. But it will not be sufficient. All an infrastructure has to be developed so that a car can refuel when necessary, maybe just for 10 minutes or 15 minutes. And so a second version is currently being standardized, what we call the semi-rapid station, with a power of 24 kilowatts. And then we can, within 5 minutes, refuel for 10 kilometers. And also, under development, another solution, more powerful at 40 kilowatts. The big question is that if you use a 3 kilowatt charging point, well, you need electrical power equivalent to a water heater, which is acceptable. During the night, you charge or recharge, it's acceptable by the network. But imagine that you need to use a fast charge. In that case, in 1 hour, you will you will need the power equivalent to what a standard building is requesting. And if you want to recharge in 3 minutes, that's the power of a district which is requested. So this is absolutely indispensable to have a management system of this station via a smart grid solution. Will it be sufficient? The answer can only maybe. So you see, the ultimate objective of smart grid would be to have a central, where will be the center? This has also to be debated. But that's a central management system which can control the production side and the demand side. Electrical vehicles participating in both sides. And the big question is, will we have in the future new way for storing electricity, such as regenerative fuel cells, new kind of batteries? I don't believe that hydrogen is a very credible solution, but some people are not of the same opinion. As a conclusion, I would like just to say that smart grids are very promising. It's a field of innovation which is absolutely fantastic. Of course, it's a little bit fashionable, but it deserves consideration. A lot of issues have to be addressed. Some of them are technical. The general architecture of the grid, more or less decentralized. The modelization, the forecasting